In section 13, we look at imaginary and complex numbers. The use of the calculator is not allowed in this section. Starting out with the definition of an imaginary number is one that when squared gives a negative result. They are written like a real number, but with the letter I after them, where I is equal to the square root of -1. The numbers below are all imaginary. If we took the square root of +16, it would give us 4. So we can kind of think of this as the square root of 16 times the square root of -1, where the square root of 16 turns into a 4 and the square root of -1 turns into an I. Same thing with the next one. I can kind of think of this as the square root of 36 times the square root of -1, where the square root of 36 becomes 6 and the square root of -1 becomes I. And then for this one, the square root of 4 times the square root of -1 would give me the square root of 4 is 2, and then the square root of -1 is I. Another thing to remember here is just when we see that negative, if it's an even root like this, the I just automatically comes out. Imaginary numbers are cyclic with a cycle length of 4. So when we look at I, by definition, we know that that's equal to the square root of -1. When we go to find I squared, we would square both sides here, and so what we get then is -1. Squaring that top one, squaring the square root of -1 would just eliminate that square root, and we would just be left with that -1. Now, I to the third is the same thing as having I squared, which we just talked about, times I, because again, when they have the same base, we would add their exponents together. So since I squared turns into a -1 and I is just going to be left as I, we're going to get -I for this. And then the last one that we look at here is I to the fourth. And we can think of the I to the fourth in a few different ways, but the easiest thing to look at is I squared times I squared. It's equivalent to I to the fourth, and we know based on what we did up here that I squared is -1. So this becomes -1 times -1, which becomes a +1. And it's important that we have all 4 of these memorized. If we continue to go on, I would next be looking at I to the fifth. Now, anything beyond this, I want to start by thinking about I to the fourth or some multiple of 4, because any that is divisible by 4, any of the exponents that are divisible by 4 with these are going to just turn into a 1. So whether I have I to the fourth or I to the 8th or I to the 12th or I to the 16th, and I could keep going, each of those parts would just turn into a 1. And so in this case, I've got I to the fourth, which is a 1, times I. The I don't have to convert to anything else. I just leave it as I. I to the sixth is the same thing as me having I to the fourth times I to the second. So then the I to the fourth again is just going to kind of cancel, or we can think of it as 1. And then I squared we know turns into a -1. 1 times -1 gives me -1. For I to the seventh, I can rewrite that as I to the fourth times I to the third, because again, they add up, their exponents add up to give me 7. Again, the I to the fourth becomes a 1, I to the third becomes a -I, and therefore my answer is going to be -I. And then for I to the eighth, you can think of it as I to the fourth times I to the fourth, or you can just remember that because this is perfectly divisible by 4, it is just going to turn into a 1. So based on this cycle here, we're going to answer some questions. So for number 1, the imaginary number I to the sixth can be written as which of the following? So again, we want to break this down and think of it as I to the fourth times I to the second, because 4 is the highest power that we can take out of 6 that would be divisible by 4. And then that I to the fourth is just going to turn into a 1. So I'm going to basically just cancel that, and I'm left with I squared. So then I'd want to have memorized that I squared is equal to -1, therefore B is the answer here. Number 2, we've got I to the seventh. So again, I want to think, how many sets of 4 can I take out here? And in that case, it's just 1, because if I try to do I to the eighth, that's going too big here. So now I've got I to the fourth times I to the third. Once again, I to the fourth is going to cancel, and all I have left is I to the third. And we want to have that memorized, that I to the third is equal to -I. So C. For number 3, if I have I to the 11th, once again, I want to think about what's the highest power I can take out of 11 that's divisible by 4. So 4 would work. 8 would also work. If I tried to go to 12, 12 would be too big. So I'm going to have to go with 8. And then I want to think about how many more I need so that it still adds up to be 11. Once I've got I to the 8th and I to the 3rd, I to the 8th is again going to cancel, and I'm left with I to the 3rd. From there, I to the 3rd by definition turns into negative I, therefore C is the correct answer. For number 4, if I have I to the 13th, again, 4 would work, 8 would work, 12 would work. If I went beyond that to 16, 16 does not work. So for this one, I think of it as I to the 12th, and then I just need one more to give me that sum of 13 there. Now I to the 12th will cancel, and I'm just left with I to the 1st, which is just I. So next we're looking at 4I plus 2I to the 3rd. We cannot combine these as they stand right now. Anytime we have a degree higher than 1 on our imaginary number, we need to convert that. So I to the 3rd is going to turn into a negative I. So this becomes 2 times negative I, which gives me negative 2I. Now from here, these are considered like terms. I can do 4I plus negative 2I to give me 2I. Next, if we're looking at 8 plus 4I squared, once again, as soon as I see a power on I, I've got to change that. I squared is going to turn into a negative 1. Therefore, I've got the 8 I'm leaving alone, but 4 times negative 1 is going to give me negative 4. And as I combine those, I do get positive 4. Now for 6I squared minus 4I to the 4th, once again, I've got to change both of these. I squared turns into a negative 1, so this is going to be a negative 6. I to the 4th is really just going to cancel, so I'm left with negative 6 minus 4, which combines to give me negative 10. Now I'd like you to try examples 5 through 10 on your own. You're also going to classify them as an imaginary number or as a real number. And now we look at the answers for these. So we can see that in number 5, when we see that I squared, it's going to turn into a negative 1. So we've got 3 times negative 1, which gives me negative 3 here. Over here, I to the 4th is really just going to cancel or become a 1. So I've got minus 5. So negative 3 and negative 5 combined give me negative 8. For number 6, I to the 3rd is going to change into negative I. So now I'll have 8 times negative I, which is negative 8I, plus this one I can leave alone, 2I, and then minus I to the 5th. Again, I want to think of this as I to the 4th times I to the 1st. That way the I to the 4th goes away, and I'm really just left with minus I. So now as I combine these, I've got negative 8I plus 2I, so I'm at negative 6I minus 1I, and that is going to combine to give me negative 7I. For number 7, I've got 6I to the 8th. As soon as I see that that 8 is divisible by 4, I know that that is going to cancel out or become a 1. So that's why I'm just left with 6 here. Over here, I to the 6th is the same thing as I to the 4th times I squared. I to the 4th is going to cancel or become a 1. I squared makes that a negative 1. So now I've got negative 7 times negative 1, which turns that into a positive 7. And 6 and 7 add together to give me 13. For number 8, I to the 3rd is going to turn into a negative I. So now I've got 6 times negative I, which is negative 6I. Over here, I to the 5th is going to be the same thing as I to the 4th times I to the 1st. The I to the 4th part cancels, so I'm left with negative 5 times I, which is what I have right here. So from here, negative 6I and negative 5I combine to give me negative 11I. In number 9, I to the 4th is going to cancel or just become a 1. So that part's just going to be 4. The I squared here is going to change into a negative 1. So I've got 9 times negative 1, which is going to be negative 9. And then over here, I to the 6th, I'm going to think of as I to the 4th times I to the 2nd. The I to the 4th part cancels. I squared turns into a negative 1. So here I've got a negative 1, which is going to make this become a positive 1. And that's going to give me a final result of negative 4. And then finally for number 10, I to the 7th, I'm going to think of as I to the 4th times I to the 3rd. I to the 4th is going to cancel. I to the 3rd turns into a negative I. So we have 3 times negative I here, which will be negative 3I. And then here, I to the 5th is the same thing as I to the 4th times I to the 1st. So the I to the 4th part is canceling. Then I've got negative 2 times I left, which gives me negative 2I. And then negative 3I and negative 2I will combine to give me negative 5I. Now, the last thing we should talk about with these problems is to classify them as being imaginary or real. And if they have an I in them, they're going to be considered imaginary. If they don't, they're going to be considered a real number. So number 5 is going to be a real number. 6 would have been imaginary. 7 is real. 8 imaginary. 9 is real. And 10 is imaginary. So number 11 is a select all that applies. So we can get multiple answers here. Which of the computations below will result in a real number for an answer? So I'm looking at A. I've got I squared, which is going to turn into -1. Then I've got minus I to the 4th, which turns into a +1. Since I have no i's left here, I know that A is going to work. For B, I to the 3rd is going to turn into a -I. I to the 5th, I will think of as I to the 4th times I. The I to the 4th part goes away, so that's just going to be a +I. So if I had a -I plus an I, this is going to be 0, which is going to be a real number. For C, that 5I is going to stay exactly how it is. This over here is going to turn into a -2I. When I go to combine them, I will still have an I in the problem, so this one's going to get eliminated. That will not be a real number. For D, I'm going to have 7I, and then -4. We've got I to the 4th times I to the 3rd. The I to the 4th part is going to turn into a 1. The I to the 3rd part is going to be a -I. So this is going to turn into a +4I here. But either way, we won't be able to cancel our i's in this one. So this is going to stay imaginary. And then for E, this I to the 4th is going to cancel. The I to the 8th will also cancel because that exponent is divisible by 4. So I end up with 6 minus 4 here, which is 2, and that is a real number. So answers are A, B, and E. Number 12 is also select all that applies, and this time we're looking for which ones are going to result in imaginary numbers. Well, these are the same problems that we just looked at in the previous example, so it's going to be C and D that end up giving us imaginary numbers. Now we talk about complex numbers. A complex number is a number which consists of both a real number and an imaginary number. Complex numbers are written in the form A plus BI, where A and B are non-zero. Examples of complex numbers are as follows. So you can see in each of these examples, we have a part that doesn't have an I, which is the real part, and then we have a part that has the I, which is the imaginary part. Next, we want to rewrite each of the following as an imaginary number. So take a few minutes to try to do that. And these should be your answers for those. The square root of -4 is going to be, we're going to think of that as the square root of 4 times the square root of -1. The square root of 4 gives me 2, the square root of -1 gives me I. For 14, the square root of 9 would give me 3, the square root of -1 would give me I. For this one, the square root of 16 gives me 4, the square root of -1 gives me I. For 16, that negative out in front is going to stay out in front. Then the square root of 25 is 5, and the square root of a -1 gives me I. And then here, the square root of 49 is 7. The square root of a negative is going to be I. So now we're going to rewrite each of these expressions in the form A plus BI. You'll notice that we just did some of these computations in the previous examples. So for 13B, I've got 2 plus 2I. And then I'm going to be looking at, can they combine? Do I need to rearrange the order? So with that in mind, go ahead and do 14 through 17. And here is what we should be getting for those answers. For 14B, the square root of -9 we saw up here is going to be 3I. So I would get 3I plus 8. But again, they have to go in this order where it's the real part first and the imaginary part second. So I had to flip those around. For 15B, I have 6 minus, and then we talked about this part a minute ago. That part turns into 4I. So if I have 6 minus 4I, again, nothing can combine. I've got the real part first and the imaginary part second, so we're good so far. For this one, I've got a negative square root of -25, which is what we did up here. So this part's going to turn into -5I, and then I still have -2. Again, I cannot combine them, but I can switch the order so that it's -2 minus 5I. For 17B, the square root of -49 is going to be 7I, so I get 7I plus 4, and then again, I do need to switch the order of that. So now we're going to do a little bit of simplifying for these problems, and we do want to classify our number as being real. So that's if there's just a real number, imaginary if there's just an imaginary, or if you have both, then it's going to be considered complex. So for 18, we want to think of that as being 5i times 5i times 5i. 5 times 5 times 5 is going to be 125. I times I is I to the third. Since I to the third is the same thing as negative I, we've got 125 times negative I, which is negative 125i. Because this only has an I in it, this is going to be considered imaginary. For number 19, as I look to combine like terms here, I've got 2 and 4, which gives me 6. Then I've got 4i minus 1i, which is going to be 3i. And I can't do any other combining here. I do have a real part and an imaginary part, which makes this complex. And then for 20, as soon as I see that I to the fourth, I know that that's going to be a 1, so I just get 7 here. And because it's just a real number, it is just considered real. So try the next 3 examples on your own. And here are our answers. In 21, we did 6 minus 8 to get negative 2, and then that 3i had nothing to combine with or no exponent that I needed to simplify. Again, because I have a real part and imaginary part, this is considered complex. For 22, I do have some simplifying to do. I'm not allowed to have this as the square root of a negative. So right away, I want to convert this and make this become the square root of 9, which is 3, the square root of negative 1, which gives me I. From here, 8i and 3i can combine to give me 11i, and that negative 3 had nothing to combine with, but again, the real part should go first. So we write that as negative 3 plus 11i, and that's going to be considered complex. Again, it has a real and an imaginary part. For 23, we do have some simplifying to do. We're not allowed to leave these degrees being greater than 1 here. So right away, when I'm rearranging this, the negative 4 can stay negative 4. I to the third turns this into a negative I. So this is negative 5 times negative I, which makes it positive 5i. Then I have plus 4. And then right here, I to the fifth is the same thing as I to the fourth times I to the first. I to the fourth cancels, and I'm just left with I. So then I've got negative 2 times I, which gives me negative 2i. Finally, as I combine, negative 4 and 4 are going to cancel each other. 5i minus 2i is going to be written as 3i, and then that's just imaginary. Now go ahead and try 24 through 26 on your own. And here are those answers. So here you can see we left the 9i alone, we left the 5 alone, we left the negative 7i alone. It's just the 2i to the third that we need to switch. I to the third becomes negative I. 2 times negative I is negative 2i. And then from there, as I go to combine, the 5 is definitely going to be part of my answer because it has nothing to combine with. But then as I go to combine 9i minus 7i minus 2i, those all cancel. So I'm just left with a 5, which means that this is considered real. For 25, I don't have any exponents to worry about here on the i's, but I do have to combine 12 and negative 2 to give me 10. And then negative I and 5i will combine to give me 4i. Again, because I have a real part and an imaginary part, this is going to be considered complex. And then for 26, I to the fourth is going to be 1. Then I keep this as a minus 3. And then the square root of negative 4 is going to become 2i. From here, 1 minus 3 will combine to give me negative 2, and then I still have 2i. And because I have a real part and an imaginary part, that is going to be complex. Go ahead and try these next 3, 27 through 29. And here are those answers. So with this one, 7 minus 9, I don't have to do anything with that just yet. The square root of negative 16 is going to be 4i. 7 minus 9 combines to give me negative 2, and then that positive 4i will stay 4i. I have a real part and an imaginary part, therefore it's complex. In 28, I've got negative 6 and negative 1 combining to give me negative 7. Then I've got negative 7i and negative 3i combining to give me negative 10i. I have a real part and an imaginary part, which again means it's complex. And then finally for 29, if I write that out twice, I've got negative 5 times negative 5, which is 25. I times I is I squared. And then I squared is going to turn into a negative 1. So 25 times negative 1 gives me an answer of negative 25, which is real. So now please complete the exit slip, and for homework you are working on practice set 13.